broadcast our lives live.
Yeah. Hello, everybody.
We hope we're live. It's not like we sure we're live, but
yeah, we are live. Yes.
Just give me 1 second. I will check it. Hey,
yeah,
hi, Mikhail.
Hey.
Yeah, I'm actually not able to check if we are live or not. So let's just.
Yeah, I just checked. So I'll be
okay. Anyway, guys, let's get started. Yeah, welcome everybody who decided to join us today. It's a pleasure to meet you, and it's a pleasure to have this hosting and speaking about my first open source project, DevOps. I call it GooseOps. So today we're gonna have a look at this. So let's start from introducing us. So we are developers, the same developers as you are, maybe. And we called ourselves X Technology. So we host educational developer open source project. Is to actually learn something new, to share this experience and knowledge with others, and actually collaborate and build all together something interesting. For sure, have some fun. So my name Andrew. I have a company called Emma. I do some backend engineer role there, but also heading over some experience and basically some stuff which we'll be speaking today about it. So the next guy is Alex. Let him introduce himself.
Interesting time we live. I remember the first meetup we did, and we had a expert guest, we called it Andrew. So now you're presenting your project. Nice. Hi, I'm Alex. I'm also a developer. Actually, a good friend of Igor and Andrew. I'm based in Amsterdam currently, and I'm working in an IT company, ING. It's a huge bank in Europe. Yeah, my previous experience is JavaScript mainly, but nowadays I switched to Golang and Java Stack. And actually I had some DevOps background as well, but that was for front end. So I'm actually I touched these technologies that Andrew gonna talk today, but not deep enough, I would say. So I have some amount of questions. Speaking of which, feel free to post any question to YouTube. That's the format, the current format that you cannot say it out loud. But if you post something, we will try to immediately catch Andrew, and I'll let him answer that. Yeah, that's me.
Great. So I suppose I'm the next one to be introduced.
Right. Yeah.
Yeah. So hi, I'm Igor. I'm also a friend of Alex and Andrew. Now it's a gang of 3. That's great. We are growing 50% per month at least. I'm a data scientist. Now I'm working in a consultancy company called Crayon. It is I am based in Vienna. And for the last 5 or 6 years, I worked in different companies as a data scientist. But now I would like to be more experienced into engineering topics. So that's why this DevOps stuff is really super exciting to me. So I hope after today's session, I will get to know a lot of new and cool things. And I also will ask a lot of stupid questions, so don't be bothered by them.
You know that there are no stupid questions, right? It's like
depends. You'll see.
Actually, it's cool when you develop when you are developing some open source project, and then you can share this experience and actually project other team members to help them to push their own goals on their own project. That's why we are here, actually.
Exactly. We will utilize your project in ours.
Yeah.
That is my hope.
So let's get started. I will start from the idea. So why and how I decided to develop something like that. So the main reason was like all the time I had experience developing different projects as outsource guy, and also like a full-time or part-time member of the different teams, different technologies inside. So, but mostly what was common to all these technologies is the requirement to push things faster to the production, to show it to managers, to actually show it to users, to have ability to do some A/B testing, to realize what UI is better, what button is, what color of button is more selling more, and that's why there are some techniques which helps you to do that. And here we will talk about DevOps. Is a set of practices that combines software development and IT operations. It aims to, in shortened time, move things to the life and deliver it with some appropriate quality. So yeah, when I started for Teva, my project, we have some developers inside this team, so we need to convince them, and actually I'm a special tool which for them as developers, they don't need to know how this magic happens. They just need to do their own stuff, develop, because they're interested in that. And my goal and our goal to take care of the rest. So when they develop something, we create a pull request, and then they just can press the button. This pull request will appear somewhere in some staging environment, and they can present it. If everything is good, they just press another button, and it will be live. As easy as that. Yeah, and from company to company, when I was switching, I had the same problems, and I actually was at the beginning I was developing and doing similar stuff to be able to adopt these practices, DevOps practices. The difference was in these companies, like they hosted code in different host storages like GitHub, Gitlab, Bitbucket maybe. And they use different CI/CD services. They use different cloud providers to host their infrastructure. But in common, it has the same idea how you can do this and what you can do this or achieve these DevOps things. So today we're not actually going to reinvent the bicycle. We're just going to touch all these micro tools and big tools as well, which helps you to actually do some DevOps stuff. And maybe on the next section, we actually will be able to combine all this together and see how it works. But for today, we also have a lot of examples which helps to understand how it works underneath. So today we're gonna try Docker Kubernetes and have some view into the Helm, how it helps to template your Kubernetes applications and deliver them as well. And we're gonna try Terraform language to create and automate our infrastructure. So basically, by the end of this hour, we're gonna have some kind of domain DNS record into our created Kubernetes cluster, and we're gonna deliver there some our magic code which has to be executed and it has to return us some output. So let's move on. And the first topic is I'm gonna speak about Docker. So Docker is a kind of a tool which really helpful. For now, it operates on it uses operation system level virtualization, and it allows developers and DevOps guys deliver the software packed in the packages called containers. So containers are isolated one from each other, and we can actually define how they should be connected to each other for some network or whatever. And so to create our first container, we need to write Dockerfile. Dockerfile is a definition of commands which has to be executed to create an image. So imagine image, it's something like a floppy disk, for example. So you write some information on your floppy disk, and then after it's done, you can insert this of flashcard. Okay, more common example. So we have a flashcard. We put some software on this flashcard, and any device which are capable to run this software from the flashcard, we can just insert it and run it. So that's let's imagine that this flashcard, it's an image, Docker image, and we're gonna start with defining Dockerfile to create our first Docker image from here. So here is our first very simple Dockerfile. What it does, any Docker file has section from. It defines from which image it starts from. So, for example, we start from Nginx, which is installed on the Alpine image, which is very shortened version of Linux-based images. So we define here work directory where our code will be stored, and then we copy everything what we have in our src folder into the HTML folder. So HTML folder from the Nginx image is something which will be by default executed. So if you just put in this folder any HTML files, it will be executed without any pain. So to simplify the example, we just do simple HTML application here. So also we define, we tell Docker which port will be exposed. So when Docker when we run this Docker container, Docker platform will understand that on this container it can be connected to the port 18. And we also have to define the command. So command, it's actually a thing which will be executed when you run this Docker container. So in the moment when this program will fail or will stop, the container will stop as well. So this is a kind of a very strange, maybe odd thing about Docker, but it allows you to simplify the process that every container has to have only one program inside, one main process, basically. There are some tools which allows you to add extra processes as well in the same container, but it's not really good practice to do that. So we have our Docker image here defined, and we're gonna run Nginx. So let's see what we actually have in the folder src, which we're gonna insert there. So we have a simple application in Indexhtml, which has some title and has some, let's inspect it, has some image inside. So just show you for the next example. So it's an image taken from the assets. So we're gonna copy all the SSRC files like assets and Indexhtml. So let's try. I will have an example here somewhere. So we're gonna build. By the way, if you run without defining which Docker file to use, as you see, we have here two of them. It will use Dockerfile, this one by default. So we're gonna tell him that. We're gonna tell him that we want to use actually another file. It's called your file static, and we're gonna build it. So -t option defines which tag we're gonna call it. Tag is something like how we call this application. Then we are able to run it using this tag. So let's build it. So as you see, it went through very fast. It's another cool and interesting feature about Docker. So it's every comment here in this file is like a when you write it, every comment is gonna be like a pie with different slices on top of it. So if you change something in the middle, so Docker will use this from cache, and here you see some new comment, and all the rest will be rebuilt. So let's do something like that by just changing like that, for example. Okay, it's fast. It's fast anyway, like that. Okay, you see, it's processing all the files and trying to build them, trying to copy another folder. Anyway, let's go back everything. So what we have by the final, we have a container. We have an image which inside contains nginx, and inside of this nginx in the HTML folder we have this assets and Indexhtml. So for now we're gonna run it by following commands. So here we define the tag. So the one which I just built, define it during the build process. So we run it like docker run --rm. This is interesting flag. I usually use it. So that means when the container stopped, it will remove it. Docker is a cool tool, but when it's actually when you use it very often, it's just gonna eat all your space on your hard drive, and this is not really cool. So we are running. We see some output. This output created by the nginx and actually entry point, which was defined in this image. But by -p flag, we define that we want to bind our local 8080 port to the internal container port 80. So now we can see we are able to enter here like that, and we see our application which processed from the Docker container. If we just close it, it's not gonna be surfing anymore. Let's go further and see on another Docker file, which has a bit more complicated example. It has a, I would say, multi-step build process when we use one Docker file to build everything, and another Docker file to actually use this build image and just copy the output of the output which was created in the build folder into our HTML folder. So what's the difference here? We just we just trying to replace our real asset. So we don't want to copy assets folder as well. So we just moving this image to base 64 form and insert it in the index.html. That's it. And then we just copy this result into our new Docker. So now we're gonna run it without this -f flag, which will be executed by default with Dockerfile. And now we're gonna run it again and see the difference. So here you can see that image already served not from the assets, from the external assets, but we use instead base 64 instead of it. This process very useful for applications, for example, based on Node.js or also based on Go, when you need to, for building, you have to have some certain environment around you, and you have to have some certain developer packages installed to build everything. But then you just copy it to the more thin container, more thin image, and you can use it more. You can use it better in a better form. Okay.
Andrew, maybe could I stop you here?
Yeah.
Because I think I'm getting the whole picture, and as I don't have experience in software engineering, I have many questions. So the first string, which is from Alpine and something, that means that we're looking into another Docker which was already created before us, right?
Yeah. So So yeah, about another thing about Docker. So we have images which can be created by using this Dockerfile. We have containers, which is a result of our images when we just run some particular image. And also we have another thing. It's called Docker registry. It's it's some storage, like we have GitHub, for example, where we can store our code, and this is a home for our images. So when we created an image, we can push it in some external thing, and then all other guys can just download your image and use it. So the same we have about Alpine. For example, if I enter here Alpine, I will see the same, like here is it, you can find 10 million, 1 billion downloads. That's cool. And here you can see tags. So tag, it's like this thing we just defined. So this is the name of our image, which is hosted on the Docker registry. And this is our tag. So by tag, we mean some specific version of this software which crafted inside. So here, actually, we didn't use any particular things, but for example, if we're gonna use Node.js, we maybe need to run some apt-get here to install extra tools we need. For example, I don't know, something related to certificates or some other particular packages we need to have inside, which is very convenient. In this case, you don't need to install all these things on host machine. So on the host machine, you just need to run Docker daemon, which will run all the Docker images you provide.
Can I ask the next one maybe? Sorry. So this is a setup I also use with the double images. But can you remind me, like, how that works in the end? To take the last image as a base one to build a new one, or you specify which is gonna be the base for created image?
Yeah, I think it will use the last one by default. But for example, I had an experience having here like not things like for multistep, but maybe yeah for multistep. But here we can have like that. So this will be our default stuff, and here we will have as another static. And then when you build, if you don't define anything, this last stuff will be executed. But if you define another static, this another static will be built, and you will have another image. Actually, it's quite useful when you, for example, when you build some Node.js application, and after the build you have some static files, and instead of these static files be served by Node.js, you want to have another Nginx in here, and you just copy all the static files into this Nginx image, and in your orchestration tool, you just put it. So if static files requested, it will be served by Nginx. If other REST stuff requested, it will be served by Node.js application.
Okay, thanks. And the last one by now from my side. Yeah, I actually yesterday ran into some investigation into rootless image. I don't know if you heard about that. Maybe you can also define it a little bit, just to refresh my my knowledge. But the actual question I have: do you know what's the entry point versus command, and do you have a preference of using either of those?
Sorry, could you please repeat?
Yeah, there is a command, cmd command. Yeah, that one I actually don't see in the current Dockerfile you're showing, but you can also use the entry point. And yeah, I checked. I checked what's the difference. It's kind of clear, but I'm yeah, just like to know if you have any preference, which one you use. And
it depends. For example, I give you a example from my life. So we have a monorepo application. So many different services are located in one repository, and we have one Docker file which has an entry point. And this entry point looks like we need to run, for example, Node.js, and then as a parameter, so it's gonna be like that, something like that. Not sure. So we're gonna run Node.js, and then the parameter which we passed after the image will be executed. And this is useful when you understand that Node.js is an entry point for all your applications stored inside, and you can run it like. So, for example, here we can define run up 1, up 2, up 3. And what's gonna happen here? It's actually will run a command not up 1, not up 2, not up 3.
Okay, cool.
So entry point is something, yeah, you can define as the starting point for your image, and you can extend it with some arguments inside.
Okay. Yep. Thanks.
Okay, so we're gonna move on. Let's see what we have left. So yeah, here's the command to push actually everything what we coded. So let's just hit the build to make sure that it's the latest one, and push it into the remote repository. So you can see it uses like Docker IO. This is a Docker Hub default. It says like version 1 was successfully like delivered there. Basically, it's saying like all layers. As I was telling about multi-layer pie about image. When you push it, it also checks if something was changed. So it checks this string the same, this the same, this the same, this the same, this the same. So it's basically doing nothing in here because the image already there and it's fully the same. Another useful tool about Docker, which I learned basically for local development, it's called DrCompose. I forgot to add it into the documentation here, but anyway, it's very useful when you have multiple services. In this application, we have an example, just one service, but in more complex ways, you have here like MySQL something, you have another thing, and a lot of other things. And usually for developers, when they come for a new company, it's quite hard to start with all these stacks, which basically new for them. And Dockerfile, DrCompose simplifies this starting point. So you have this DrCompose, you have Dockerfile, and you have Docker installed. That's the only thing you need for starting your development process. So let's see how it works. Let's just check if this is not running. And the simplest command is just saying up. So we are saying to this DrCompose to up to start all the applications we have inside, and it will be forwarding all the output in our console log. So you see it also adds like the name of the application. If we're gonna have here a database, it will be also marked as the output from the database instead, which is quite useful when you develop something. And you can here see that started to work. So what we're gonna do, we can go here and change something and just add in another word. Okay, it's not working for some reason. Or it maybe is.
But shouldn't you restart DrCompose, or it's watching the file changes?
Yeah. In more complex examples, you have to define how some watchers need to see into your application and actually rebuild it like in live. But in this example, we have just a simple HTML which served by Nginx, and when we replace it, it replaced here. And this replacing actually done by specific stuff called volumes. So here we define that we're gonna build this image. So we have image crafted from Dockerfile, so this one. But finally, at the end, when we run the container, this container, we say that like we want to replace from our SRC folder, we're gonna replace it and put it in the HTML folder. That's why when I change something here, it will appear in here. Yeah. So it's a little intro about Docker and DrCompose, which I really like. Basically, this is the first thing what I do in new project when I come into a new company. If they don't have this stuff, it really helps developers to start with, and it helps me to deliver this software faster and in more robust way. So, do you have guys any questions about DrCompose, so we can go further?
No, just a comment. I fully agree with Docker as a tool. Yeah, it's like a second best tool for me after Git, of course. What do you think?
Yeah.
Okay.
Yeah, that's cool. I already forgot when I was installing the particular software on my local machine, because for now it's just not needed. The only thing you need to have a quite huge hard drive, somehow to define to the Docker that you have limited amount of space which you can use because it's gonna eat all your space. Yeah, so let's move on. So next, I want to speak about Kubernetes. It's another tool was developed by Google at the beginning, which they used in the internal stuff, but then they decided to put it out first. And actually, this is my second tool after Docker, maybe, which I really excited of because it allows you to deliver your software with a very smart way into the clouds. So most of the cloud providers, not most, maybe all of them already, they support Kubernetes. So it's a container orchestration system or platform which allows you to automate your deployment delivery, scaling, and management, which is very useful when you have a special file where you define how your application has to be delivered, has to be defined into this cluster, and Kubernetes just does the rest. So you pass him this file, and everything the rest will be executed by it. Yeah. So what is cluster? Cluster is some kind of theme which combines inside of it multiple amount of servers, and from developer side we don't need to think where this server, how it's how it's processed. We just need to know everything about Kubernetes and how to deliver this into this. In the moment when we think and when we see that there is not enough resources in this cluster, basically when some particular application started consuming a lot of memory or a lot of CPU, we can just easily add new servers into this cluster, and it will extend like a magic. Yeah. So as I said, Kubernetes understands some definitions where we define how we're gonna deliver our software, how networking should be processed between this software, and how it should be described to understand all this stuff. So let's get started from the simplest and most popular thing. It's called Ingress. Ingress allows us to accept any external traffic from the real clients from the other world and accept this traffic into our cluster. And then when this is accepted, it can decide to which particular application this has to be routed. So, for example, on this picture, you can see like we have Ingress and we have two different hosts in there, which leads to two different applications, services, and two different applications.
Andrew, the Ingress is basically some third-party image that can be put into Kubernetes cluster and works like load balancer. Is that correct understanding?
Yeah. It's kind of, but it works like load balancer in the sense of one node. So, for example, we have two nodes connected to the cluster, and we say like we want to install our Ingress controller, which will be taking care of all the incoming traffic to both these nodes. So what that means? Two of these nodes have some IP addresses, and both of these nodes can accept traffic. If we decide to install this Ingress controller only on one node, only this node can accept traffic. And then, by this definition of Ingress, we tell Ingress controller that when the traffic is accepted, we're gonna listen for this domain name, and we're gonna route this traffic to this service called GooseOps on the board. 80. And yeah, answering to your question, the most simplest way to use an image in Nginx, but there are different images available which you can use instead as an Ingress class here. It will be processed by different applications, but all the rest stuff will be the same for you.
Okay, thanks.
Yeah, and let's go deeper. So we have service. It's not presented here for some reason, but then we have deployment. So deployment, it's a definition which describes how we want to see our application inside the cluster. We define how many replicas it should have, which container it should use, and so on, which ports it will be binded, how much resources that it has to consume. And so we say this to Kubernetes like our wish. So we want this to be happen. And what happened, what deployment does, it actually takes care of this to happen. So if we define here like three replicas, and there are no enough resources in the Kubernetes cluster, and it was capable to run just 2 replicas, it will show you like a error message saying like you don't have enough resources in the cluster. You have to put one more node in there. And when you do this, actually, this deployment will take care of rolling out the missing replica, and you will have 3 applications after that. So it's watching into your definition, and it tries to do everything to make it happen what you defined there. So let's move on. We have several comments. I already have installed this Kubernetes cluster. I will show later how into the cloud. We can discover some comments. Okay. We're not gonna discover some comments.
No big questions I can see in the chat. But if you have any, please feel free to ask, and I will immediately interrupt Andrew as I always do.
Okay. So yeah, let's have a look. So here I already, as I said, I have installed cluster before. I have it in Terraform folder. So it created, after the install, created a file called config.yaml. It actually describes all the information about cluster and how I can connect to it and all the stuff. And since after that, I can use kubectl commands to get some information from my cluster, so I can see all the namespaces inside, for example. So here are 2 namespaces I've created by myself. It's called dev and prod. And this is 2 namespaces I'm gonna deliver our applications, like for development and for production. And let's see what we have in development. For example, what deploy we have. Minus n means namespace. So we define that we're gonna look into the dev namespace, and we want to ask, give me some deployments we have. And it says like we have 1 deployment called GooseOps. It's ready and it's working up to date. Up to date means like we delivered, for example, new definition, and it's synchronized with this new definition already, and it's available. Okay. So what else we can see? We can see our ingress. It's also defined. It's called GooseOps. It's gonna accept traffic from the domain name dev.goose.dev on this IP address and port 80. For example, if we want to see what was the definition of this ingress, we can put -o YAML, and it will output our definition in here, the same which we have here. Yeah. Some of the commands I used to use very often, which when some shit happens, usually that happens, you cannot prevent that. We can see pod. Pod is an instance of application which running on behalf of deployment. So deployment just takes care of pods. It says like we need to run some pod or we need to stop some pod. And when you do a deployment, what actually happens? First of all, it runs another pod. It waits until this new pod is ready to accept traffic. When it happens, it just switches the traffic to the new pod, and after that, it removes the old pod. That practice allows us to do very safe deployments to production or any environment, which shouldn't harm any existing users. So yeah, let's see the comment I wanted you to show. It's called exec. So we're gonna go into our pod running somewhere in the cluster in this magical thing, and I'm gonna go in and see if there's something wrong inside, maybe. So I just logged in into the pod. If I do ls-lr, those.
So in here, you basically connecting to a running container in your Kubernetes configuration, right? So, okay,
yeah.
Nice. And that's basically the way how you debug your application. That's just the default way of doing that.
Yeah. It's very useful. However, when you're taking care of security of your application as well, usually inside the Docker, you're gonna the user. So by default, this is gonna be executed from the root user, which is not really good practice. So usually here we're gonna create a new user, give him some rights on this particular folder, and only for executing something, some particular Nginx or whatever. And right after that, you can log in here, but you cannot actually do something. But for now, I can do like okay, do some updates. I can install or add. I can add Vim. That's a new command, and do some like. So I just installed the editor inside the container running somewhere. It's useful when you're debugging, and
I assume that in for security reasons, when you run in some production ready cluster, you disallow basically the execution of bin shell for the Okay, and also running commands from a root from the root access also.
So for example, what happens usually? What happens with Go application when you create a binary, you put it in a like fully empty image. So literally in this image, you just have this binary, and you have just rights to execute this binary and nothing more. So whatever you do, you won't even be able to log in like into the bash or shell in here after that. So okay, I exited that. So another very useful tool for debugging, which I use quite often. Let's see services in here. Oh yeah, get. I don't have this. Okay. Let me try to remember myself. Something like that. No, that. Port forward. Let's see in the help.
So what's happening now?
I want to forward my local port 8090 to the service which is running somewhere in the cluster. So I will be able, for example, this service doesn't have any ingress and it just being executed just internally, locally, for being consumed by other services. So I'm not able to connect to this service from the global internet, but by using port forwarding tool, I will be able to actually do this from my local.
So that's actually one of the things which we use sometimes. So we have some cluster which, for example, has a service, a database as a service, and not. And when I want to explore this database kind of locally, I just do a port forward and I'm connecting to this external database.
I'm not really remember this this comment there, but let's see. It's anyway quite interesting. Okay, the wrong order. Okay, now you can see. Yeah.
Yeah, I want you to finish with your stuff.
Okay. So now you can see that kubectl utility just started listening on my local, like on the IPv4 and IPv6 address and forwarding all this traffic to port 80 of this service. So if I go here and change the port, I will see the application running from the Kubernetes. And here you can see that some connections was accepted. If I switch it off, it's gonna be stopped. Okay. Yeah.
So I actually have some general discussion, let's say maybe not a question. So a lot of people are now using Kubernetes, and I think it's a current status how everything should be done in production at least. But what are the alternatives? So, and how can companies operate without Kubernetes? Will it be much more complex without it, or?
Yeah, Kubernetes at the first view, at the first point of view, looks very, very hard to understand thing. But if you start with as simple things, you will get deeper and deeper, like every day, and then after a while you can imagine all this cool thing. The thing I really liked Kubernetes, that a part of the fact that it allows a lot of definitions for now, which actually allows you to define whatever you want in real. But even you cannot find the definition you want, you can create your own definition and you can create your own processing, which will be taking care of this new definition. And basically, you can invent something new and easily integrate this into the Kubernetes core, which is very extensible thing. And answering
it's called
your
a
question,
custom resource definition, right? Is that the
yeah,
part?
yeah, right. Yeah, and answering your question, before the Kubernetes, I used to touch another tool. It's called Docker Swarm. I don't know the reason why it didn't get enough extension, so it's not really popular out there, but they released this and it's out there. The thing I liked it because all the definitions looks similar, like DrCompose file with some extra information, like here we can define which particular node it has to be delivered or how many replicas you need to have. So if you used to use DrCompose before Swarm, it will be very easy for you to start with Swarm.
Mm-hmm. And let's say I have a small startup with 6 people. Does it make sense for us to use Kubernetes right away, or we should go to some point when it will make sense? Because maybe you need
I think it depends on your startup because many startups for now they don't even want to pay a penny before they understand that this idea can be profitable or not. Like by making some MVP, and before probably making some MVP, you're gonna create some landing page, which can be done easily without any Kubernetes, so you don't need to spend much time. You need to understand is this gonna be profitable? Is this a tool which people are ready to pay for? And when you understand that, yeah, after that, I think that's the time to start your Kubernetes. And for example, the place where I defined it, the starting price will be $10. So from $10 from $10 per month, you can have Kubernetes cluster with very small node, one node. But then you can, if you need more capacity, you can just extend this cluster and pay more money. But if you don't, you just pay $10 and that's it. That's probably the reason why I started with DigitalOcean. It's a cloud provider for developers, but compared to others, it's very simple, very easy. And if you really going to build some more efficient or more sophisticated tool, you're gonna look into the Google or Azure or others, which like a very extensible. And in this, but at the same point, they are more expensive compared to DigitalOcean.
So as maybe to recap, will it be true if I say that Kubernetes can substitute a small team of system administrators, I don't know, DevOps guys, who will do manual rescaling, rerouting, restarting of services?
Yeah.
Or it's slightly different? Mm-hmm.
Yeah, the main thing why to use Kubernetes or other orchestration tools, I think they do just the same stuff, that you define the state in which you want to see your cluster, your applications, and this tool will try to do that. If they cannot do this, they will inform you. But so you don't, I think that you don't even need to like hardcore administrators in your team to start with Kubernetes. You as a developer can just read some particular explanations how to do that and start with, and actually adopt this practice into your company.
Great.
Or you can invite me.
Yeah, the link will be somewhere.
Yeah, so another tool I wanted you to show, it's called Helm. Let's move here. So we have Helm command. So Helm allows you to create definitions, Kubernetes definitions, and actually do some templating on them. Templating of these definitions useful if you, for example, have.
Now I see we might have some problem with Andrew. And I honestly don't hear you, Alex. Maybe you're muted.
Sure. I said it's time for you to shine then.
Yeah, awesome. So now it's a time for us to talk about Kubernetes and Docker. And actually, going back to
Yeah.
the questions, so in ING, I suppose you utilize Kubernetes, right?
Yeah, it's an interesting one. Yeah, I'm not supposed to talk about that, I guess. But indeed,
Sorry.
we use this kind of tools, and I touched them. I made some courses. I not made. I passed some courses, but that's my whole experience with it. So yeah, that's a very huge topic, and if you're not working on it full time, it's gonna take a bit to learn it, I guess. But yeah, you have some experience as well, like port forwarding stuff.
Yeah, that's actually the main functionality which I use, because we have a cluster, like a production cluster, and there is some database which I sometimes have to explore. And in order not to recreate the same database locally, I port forward this to my local machine and query it. So yeah, but honestly, I still so for example, when you work on Azure, you can deploy your service either on Kubernetes or on container instance, which is something smaller, I suppose. I'm not entirely sure what it is. And there's always an argument kind of in the company, what should we utilize? Because Kubernetes is more expensive and it's more complex and huge. And some use cases, some projects don't need this complexity, I suppose.
Expense in terms of in performance, or
Yeah, I think the same power, I mean, the same amount of services deployed on container instances and Kubernetes cluster will cost different. Kubernetes will be more expensive. There
yeah.
should be like trade-off, I suppose. That's what I was interested in. Maybe there is some limit when you should go to Kubernetes and it will be easier, but before it will be easier for you to manage the cluster on your own.
Yeah, it's yeah, we have a huge company, so indeed we using this tooling and even more than that, and yeah, there are different solutions on top of Kubernetes, like to organize your service mesh and stuff like that. I recently heard about a thing called ISTO. That one helps to organize. Yeah, you're using that as well?
Oh, well, I hear a lot of names in my work.
Yeah.
I personally do not use it, but definitely we use it. Yeah.
Hey, if it has a logo, then you and you know what the logo is, then then you
I'm
use this
using
technology.
it.
Yeah.
Pokemon technology. There's also some
Right.
stuff which is called Selden, I suppose. I
No,
think
never heard of it.
we were talking about traffic shadowing or A/B testing.
Yeah,
But Istio,
very.
what exactly is it? I can only imagine that it helps.
Yeah, I just heard of it. I never tried myself, but it looks to me that it helps to organize API applications in yeah, with all kind of strategies used for that in environment. You know, like a load balancer can be an example, just a simple one, but there are many more things that you'd like to have as something that hosts in multiple API applications. I guess I haven't read through the documentation myself, so just
Yeah.
I don't have any news from Andrew.
Yeah, I also don't.
So,
So I don't know. Maybe we will try to recap what we heard today.
yeah, it can be. Let's wait 5 more minutes, I would say, and if he doesn't appear, we just can finish it. I think it was quite enough. We could even split this part into two or something like that, like a Helm and what is the rest? Helm and I guess Terraform. Yeah. So that quite good introduction.
Yeah.
Yeah. So we wait a few more minutes.
Yeah, maybe that could be a question for you about Docker. So when we do something in our code, we change the code base, and then we build the service, the project. Do we always repush our new container to repository, or it depends?
Yeah, I think you're pushing it from your CI/CD, right? So it's basically should be a normal process for your continuous integration. You change your code that passes a test, all kind of tests you have, unit tests, integrational tests, and if it's all good and if it's merged to your main branch, it can be pushed to your it's container registry. It's sometimes called. Or Docker registry if it's public, that's, or maybe private as well if you have a namespace in there. Yeah, I hope you're not doing that manually each time you change your code.
I personally don't. Yeah, I was just asking what is the best practice. So it's automatically is doing version controlling. I mean, it adds versions like V1, V2, V3, V4, and then.
Oh, also interesting question.
Yeah, and then when we
there is I think a discussion around that as well, like how you should tag your images built from a continuous integration of pipelines. So yeah, latest is not the best, as you can imagine, I guess.
I don't know. As I understand, latest is some default tag which just looks into the, I don't know, the date of the build.
Yes, there is some confusion I never had the experience with choosing a right strategy for Docker images for our projects. We just used a few of them, like latest and maybe some, I don't know, experimental tag, something like that. But it can be very mature actually. Like when you release some tagged version, for example, you can put this the same tag on a Docker image, and then let your customers know about that, so they stick to one version, not changing it all the time.
Makes sense. And as Andrew said, that it's not a good practice to put multiple services to one Docker, right? So if you have
what do you know about that actually?
Not that much. That's I don't know. I'm a data scientist. Let's say if I train some model and I want to publish it as an API, let's say, so that will be one of the services, right? So I should wrap this model into Docker container and publish it somewhere. And if I have another front end which has some web form which will utilize this API of my model, it will be another Docker, right? Or I could put them in one thing. Nothing will prevent me.
Yeah, I guess so. I was actually also eager for this question a year ago or something, like, do we need to have? Why don't we want to have multiple processes, main processes inside the container? And it seems to be like a well-known best practice, but you're fully free to have that. It's just easier to control your stuff when your application grows in terms of containers, and you have having Kubernetes cluster and stuff like that. Then it's gonna be a pain to stop them painless and without any troubles. I guess that's the main reason.
Yeah, that makes sense, I suppose.
Yeah. Okay, we have 1 minute. Oh, and then it's gone. So yeah, shall we wrap it up? What do you think?
Yeah, I think so. So
okay, let's announce our normal schedule, I guess. So we are trying to make this meetups every 2 weeks. We have different topics, as you know. That one was about DevOps. GooseOps it's called. Awesome name, like it said in the description.
I thought that's awesome as it's a script.
Yeah. So next time, I think, are we actually, can we announce it already, Igor?
Yeah, I think we can. So next session will be about a data science topic, a project which I'm currently doing. It's called Airbnb Analytics. And the first session was about scraping the data from the website of Airbnb. And now we're going to continue doing this, and I suppose we will finalize the data scraping. And yeah, so in 2 weeks, we're going to talk about it. And why Goose, Radicus says.
Yeah.
I think we could, only Andrew could answer that. His choice of animals. But I think he has a history about it. Maybe he will write a blog post. It's
it's funny indeed. It's yeah, I don't know. I think it doesn't have any specific meaning. It's basically the fun name, and then that's it.
Yeah.
So yeah, Airbnb Analytics, and next time, last time I think you just introduced the project, right? We tried to scrap some, well, the Airbnb website, and this time you wanted to show even more on that, right? On this topic, to basically start how to start up the Selenium and do the.
Yeah. Exactly. So before we touched on the static pages where we didn't need any specific tooling, and now we will touch the pages which are dynamic, which we can just get the HTML from, and we will utilize Selenium, and we will scrape the data which Airbnb doesn't want us to scrape.
Awesome. Yeah, you already shared some of the troubles that you had during the way, so that's an interesting journey, I guess. Then we have another project that's my part. That's called Pizza Script. Also awesome name. So that's as you can see our main theme. So yeah, the Pizza Script. I think so the Pizza Script is gonna happen in 1 year, I think. Oh, sorry, in 1 month. So that is gonna be 27th of March, if I'm counting that correctly. And the Pizza Script after a month would be the parser. So we're gonna build the new language parser. We're gonna explain it's called top-down parser algorithm, I think. Yeah, and it's to be honest, it's not the easiest. Oh yeah, I see Andrew is able to join. Andrew, hello, how are you?
I just wanted to ask you on which part you just did. I just disappeared.
Yeah, we actually are wrapping it up already. What do you think? If we leave Helm and the Terraform for the next part, what do you think about that?
Yeah, that would be good, I think. Yeah.
Yeah, we had a plenty of material already, to be honest. Like, well, it's Docker and Kubernetes, and what was the tool again? The service, the
kubectl.
Yeah, no, the other one.
Helm.
Load balancer.
Oh,
Ingress.
Ingress.
Yeah, Ingress. Yeah. So yeah, let's not keep it a huge meetup. Let's.
Yeah. Right.
Yeah. Great.
So yeah, your words. We already announced our next event. So Andrew, it's the scene is yours.
Okay. Cool. Yeah.
I'll make it like
just
that.
Just I wanted to tell you a bit more about next steps in this project. So we're gonna have a look next a bit more into the Terraform. So Terraform is a tool which allows you to describe your infrastructure as a code. So you just write a code, and when you apply this code, your infrastructure appear. For example, I've created this Kubernetes cluster with a Terraform, which is a separate topic. But it's also very useful to start with infrastructure. So next we will take a look into this, and also we're gonna automate our CI/CD with GitHub. But also later we can do this with other cloud code storages like Gitlab and Bitbucket. Make some templates to have basic information of these separate parts, so we can apply then these templates to our existing applications or existing projects, or just use these templates in our new projects to start with Kubernetes and all this infrastructure stuff quite faster. So that's the point of this project, of this topic. Yeah, that's it from my side.
We have one important question to you, or even two. The first one was why Goose?
It's interesting. Yeah, I don't know why. Actually, this picture, if you go here, so this goose, it somehow was associated with Kubernetes in some sense. Basically, goose like kind of a security security guy or security awareness guy. I don't know. But before that, I had a project and still have, and it was about scraping web scraping, and it was called Goose Parser. So this kind of stuff just continue things about Goose. Nothing personal.
The adventures of Goose.
Yeah, adventures of Goose.
Okay. Yeah, and I just had one more. So can we are we going to see some kind of article about that? Can we announce already that or
yeah, I think I will publish an article with all these steps which we had. Yeah, but not sure about the next articles for now.
Yeah. Okay. Anything to add?
I think that should be it. Was a great session.
Yeah, thank you everybody for joining us today. It was my first experience speaking to others, so I hope you liked it. Thank you very much.
I think it was a great one. Yeah. So thanks everyone for coming. Yeah.
See you next.
Yeah, see you on the next event. Yeah, join us. We have also a form if you want to join us as a speaker and as a guy who has a developer who has their own project and you want to share some experience that would be very helpful. So let's just do some stuff all together and help each other with that.
Yeah, that's right. Yeah. Okay, have a nice Saturday. Have a nice weekend. And
weekend.
Bye.
See you.
Have a nice day. Yeah, see you. Bye.